Brown Dog Gadgets live.
I think it works.
Happy Tuesday, everybody. Happy Tuesday, Pete.
Hey, what's
Who's
happening?
over there, but yeah.
I'm over here by the controls. Push, 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 push.
Oh, is your microphone on and working, Pete, this time?
It appears to be. The sound levels are moving up and down as I speak.
Let's make sure we talk in a soft NPR voice, so we don't.
If you can't hear us, please let us know.
Thank you. Today we're doing a special Brown Dog live stream. We are doing a. Pete, you talk about it. You set this up.
Yeah, I don't have a logo or anything. So Hour of Code, it's this idea that organizations work with students, kids, whatever, to help them learn code and programming. And a Milwaukee organization called Milwaukee kind of get together, organize it. So they're working with a lot of sort of corporate partners, and they somehow asked us, and we're like, hey, yeah, cool, we'll do it too. So we use code in a lot of our projects, obviously, microbit stuff, some Arduino stuff. So we'll show off some stuff today. Yeah.
Many fun projects. So we're going to show off some projects, go over the code, and then maybe even make something that's cool. I'm not going to show this because I don't think green screens.
Oh, no.
Green things on green screens is a fun idea for everybody.
Yes.
Let's just.
We need to get you a sweater or something that's green so you can just do a floating head.
I'm the floating head of Josh. like a weatherman on Halloween. I'm pretty sure that's like the go-to bit in weatherman on Halloween.
Right.
So let's go through these fun projects. Well, first and foremost, Pete, who are we? We're Brown Dog Gadgets. We're a couple of people here at Brown Dog Gadgets in beautiful Milwaukee, Wisconsin.
Yeah.
Very wonderfully warm and beautiful out here.
And what do we do here at Brown Dog Gadgets?
Well, we do a wide variety of things, making projects and guides and directions for teachers, people at home, after-school programs, scouts, 4-H, you name it. We're your arts and crafts STEM company. Yeah. Anything from little bristlebot toothbrush robots, which I don't have, so I can't hold one up, to big programming projects and everything in between. We're a fun company.
That's right.
We sell out to schools.
And we're against copper tape.
We're part of the anti-copper tape league, the League of Extraordinary Anti-Copper Tapers.
We're the creators of the tape loop.
It's true. We didn't invent the nylon tape loop, apparently.
It's true. Yeah.
Or popularized it, really popularized it.
That's right.
But anyway, if you like what you see today, don't find us too weird. We do live stream frequently, as well as post tons and tons and tons of free projects. So whether or not you like our stuff, you're like, oh, these guys are total schmucks, but their projects are cool. You can still use our stuff and not buy anything from us, or I should say our direction sets. But you can find us at all these fun social media sites. For instance, this week we posted, let's see here, a no sewing light up Christmas shirt, which was really cool. That was fun. The no-touch gumball machine. It's a gumball machine. Uses a little servo and a little distance sensor. It's actually a microbit project. You put your hand under it. Servo kicks out another gumball, goes around. It's really cool. But again, things we posted Monday and Tuesday this week, and we're posting more fun things.
Yeah.
We do tend to post a project at least every other day, if not more often.
I think we've got a flying piggy bank coming up too this week.
Oh, yes. A couple of fun, bigger microbit projects from one of our friends out in New Jersey. Sunny New Jersey. Good old sunny New Jersey.
Right, yeah, totally.
Yes, way better than old Jersey, let's just say. We do post tons of fun projects, which we'll be showing off some of them today because we do a lot of fun coding things, both for microbit and Arduino-based things. And we do have our own boards and own parts that we use, but a lot of these you can translate into pretty easily into using kind of off-the-shelf Arduino stuff or microbit stuff. We just do things in a Lego format with our specialized components, which makes it a little more kid-friendly when it comes to building things. So there you go. That's the shtick. The whole spiel. So let's.
I've got a variety of projects queued up.
Pete has actually queued up a bunch of projects, which I don't know which ones he's queued up. So we're gonna find out.
All right, we'll start with this one. We'll try this one. Let's see.
Little Josh in the corner.
Yeah. And we can hear you, obviously. So.
Oh, yeah. Is there some fun music too for it?
I'm not getting sound on this one.
I think it stopped. It's only it's a very quick
yeah, that's right. That's just the short clip. So.
It's a short clip. So this is a bubble blower.
There you go.
So this is using our new microbit adapter to our Crazy Circuit system, which is our Lego compatible robotics modular electronic system. But really all it is a push button with a microbit. We have a built-in relay on our bit board, which is the thing that goes from microbit to Lego. And we have our little tiny DC motor hooked up to that relay. And a relay is just allows you to kind of turn on. Basically, it's a smart power switch. You could control an on and off power flow to a stupid thing like a DC motor. Not that DC motors are stupid; they're not smart. You can't control them directly from a microcontroller without something in between, which is what a relay does, and then a servo with a little wand on there.
Yeah.
So pretty straightforward. And that was one of the projects that we kind of thought would be kind of fun. I think that was my idea, Pete. I think that was my fun idea.
I'm pretty sure it was.
My son, who is 2, has a little bubble blower thing. I'm like,
Yeah.
it'd be really cool if you could make like your own little tiny DIY bubble blower. You know, him being 2, he's highly amused by it. Me being not 2, also highly amused by it. But this is our code for that.
Now, Josh, when I was a kid, you had to just sit down at a screen and start typing code by hand from a magazine or a book or something, and it was basically like just staring at it and then typing, and that's how you learned. But over here we've got the make code editor, and it's using the microbit for our programming. So there's this is a fun thing. So we're using what's called blocks, but if you want to, you can use JavaScript, and it looks like this.
Pete, we're assuming that people know what microbit is.
Oh yeah, well you explain it then.
Let me do this. Let me show off. I'll show off here on the tiny Josh screen.
Yeah.
Microbit's this little dude.
And what this big shot. Big shot.
Ooh, Pete, we could use our close-up camera.
Oh, we could.
We have another camera. This is a microbit. A microbit was developed by the BBC, which is a British Broadcasting Corporation, and is a callback to a kit they put out, I think, in the 70s, ages ago.
Yeah.
But this is designed to be like a little all-in-one programming platform. There's a built-in LED display there, built-in buttons, a bunch of built-in sensors, and you can also, plug things into here, which is great. So it's a pretty simple, pretty inexpensive system, usually in that like $16 to $20, depending on the configuration. Runs off USB. They partnered with Microsoft to do that MS Make code, which is the block, drag, and drop, which is really nice and simple. But if you want to make this like a full-fledged, like much bigger, more useful system, because that's actually a decent amount of power behind it on the little tiny chip on this guy, you can use something like our Crazy Circuits bit board, which you can then just plug your microbit into, and there's just a gazillion of like different breakout boards and stuff. Ours is designed to work with Lego and to plug some other things in the side like servos and sensors and whatnot. We have our built-in relay over here, a couple little parts, which I can't, there we go. But you can always make it a lot more useful by plugging into one of the many breakout systems that are out there.
Yeah.
So, all right. That's what the microbit is. You can find that basically anywhere.
Yeah.
So let's go back to our main camera, Pete. There we go.
Main.
Oh, let's go back to the the code
Screen. There we go.
But you can find microbit literally anywhere. It's gained a lot of popularity here in the U.S. last couple of years, but it's huge in the U.K. and in Canada. I know in the U.K. I think they give like every 5th or 6th grader, something like that. Like everyone in the country got one, 5th and 6th graders.
Yeah.
So there's a big demand there for resources, materials.
Mm-hmm.
I mean, they just released a new version recently, which had additional sensors, a built-in speaker on it, like a nice update after 5 years.
Mm-hmm.
But it's nice, and $15 to $20, somewhere in there, maybe like 16 to 20, is not too much for one of those. For like a board like that.
Right.
Considering like an Arduino Uno these days, like an official one is $25.
Yeah.
Without any built-in sensors or whatnot. Though you can buy a knockoff Arduino, like all-in-one package for like that $50-ish range on Amazon with a bunch of stuff with it. But anywho, so this is one of the projects we're doing with it. And Pete, do you want to talk about your wonderful code you put together, your if and then statement?
Oh, sure. Yeah. So, so our code over here. So I should point out, typically if you've ever done like Arduino programming or any sort of microcontroller programming, you have what's called sort of the setup or the start. It's these things that happen right at the beginning of your code. And then you have sort of this forever loop where once the setup is done, it just runs that loop forever. So your program runs until, you cut the power or turn off your controller. So you give it some power, it starts up, it does its thing, and then it runs forever until you stop it, or until it'll run until you press a button or do some sort of interaction. So not that different for the microbit stuff. So there's two things we have here. We have an on start. So this is stuff that's going to happen as soon as it gets power, it's turned on. So it's going to set some of our pins to do things. So it's going to set pull pin P1 to up. What that's doing is saying, hey, when that pin sees a connection between that pin and ground, we can do something. So we're setting up that pin for use later. And then we've got a servo write. So what we're doing is on pin 0, we're saying, all right, we're going to connect the servo to this, and we want it to move to the 90-degree position. So servos move between like 0 and 180 or 270 usually. And then it's got one other thing, a digital write pin 16. Now, Josh, on the bit board, what does pin 16 do?
Well, pin 16 has all the
special,
fun. On our bit board, our breakout board, we've had pin 16 is hooked up to our relay.
Yeah.
So you can, run power through that, and
Right.
it'll act as an on and off switch, which is how we turn on that dumb DC motor.
Yep.
You can find 8, by the way, if you ever want to get to like bigger projects you want to have a light in your home that make your own clapper, basically. You can hook up like an Arduino to an AC relay, run power from your wall to it to your light, and then it could control that light on and off, because you can't control an AC, like
Right.
a random light, desk light, with an Arduino or microbit. But the relay does that handling for you. I know Pete over here once made a gigantic wall of relays and light bulbs that did fun displays, and big
Yes.
relays make a big clicking sound.
Oh, yeah.
Because on the inside, it's literally moving something back and forth.
Yeah.
They click, and just like click, 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 click. It was very amusing to listen to
It's great.
and look at. So
Oh, yeah.
depending on how many senses you use in your day, you got a full shebang
Yeah.
of stuff. That was a cool display, Pete.
Yeah, thank
did
you.
on that one.
Thank you. That was the world's largest LED cube, I think you're talking about, right? That one.
I totally forget it was that art installation you did
Yes.
downtownish.
Multiple
Back
ones.
when we used to leave
Anyway.
the house.
Yeah, done a lot of those.
Years ago. So
Right.
many years. Literally 1 or 2 ago.
Right.
But-
So on our code, like I said, we run our start and we set these pins up for either inputs or outputs, or we set them doing things. And then we jump into our forever. And again, that loop is going to run forever, waiting for something to happen. So first thing we do is we say if. You know what if is? If is like the possibilities of things happening.
Yes.
So if this digital pin number 1 goes to 0, then we're going to do all these things, and then we have this whole like else thing, like, if this happens, do this, but if not, do this other thing. So that's what we got going on there. So let's say we press that button. We're going to have our LEDs show this little thing here. And now, Josh, look, I can change the design of this
What?
however I
Pete,
want.
Pete,
Yeah.
My
no, it's-
mind is blown. And I'm a guy who
It's pretty wild, right?
mind is pretty open.
So yeah, this is this visual sort of nature of the block code programming is kind of nice because again, if you're not into typing and memorizing arcane commands or having to look them up on Google all the time, it's a lot of click and drag. And Josh, how do we get these here? There's these different sections here,
And the nice thing
you
is too, this has been as systems go, it's fairly new, like only
Yeah.
5 years old. Arduino's been out twice as long, I would think, right, Pete?
yeah, at least,
At
yeah.
least. So it's fairly quote unquote, I like to use lots of little air quotes, quote unquote new in the world. But people have done a lot of extensions for this. So if you want to say bring in like other components that aren't in the base set of materials, like say a distance sensor, you can actually add in more stuff into
you
it
can. Right
through
here,
Microsoft MakeCode
extensions.
You have to
Yeah.
find
Find
one.
all
People
these
have written
things.
them. So there's tons of stuff out there, both for like people who have done like made products for the microbit, like the ring bit car there. I imagine
Yeah.
that's a product. Oh, the Kitronics motor driver. Kitronics makes a bunch of stuff.
Yeah. Sonar's one we've used with our distance sensor.
Yep.
So,
You
yeah.
can just click on that and it'll add it to the options in your project.
Yeah, and then it adds it here, and you've got that option. And again, very simplified. So
yeah.
to add this in, you're kind of like, wait, is this it? Because in other other microcontroller settings, you probably have to add a library and then add setup and multiple lines of code. But like, it's kind of that easy.
It's one of those things, once you play around with it, you just like, yeah, I get it. And really, it's designed for people who want to make projects quickly and easily, new beginners. Pixar did not happen.
What? We showed a video.
Larry, we showed a video. God,
We had a whole video.
You should do, Pete? Let's roll that video one more time for Larry, because clearly Larry doesn't believe us.
Larry's ex-Microsoft.
Oh, is
I'll tell
he?
you that.
Ex-Microsoft. So he's like, he knows where all the gold is hidden.
Yeah,
Bill
he's-
Gates gold.
Yeah, look at that. I mean, there's our picture of it happening. So yeah, super fun project. code, pretty easy here. So Josh, look right here. If I say, you know what, I don't want to show these LEDs, boop,
What?
I just delete
Why
that.
would you not want to show the LEDs,
Well,
Pete? Why would you not want to show
maybe
them?
maybe I want to show something else. Maybe I want to show a number. Just drag that number in there and make it a number 1. 1's a good number, right? So Josh,
the
that'll show
loneliest
up.
number.
That'll show up, yeah, on that little, the little display right on the microbit. So that's fun. So Josh, back to our code here. So if we press this button, it's gonna show a number. It's gonna wait half a second, and then it's gonna say servo right. And what it's gonna do is lower that arm with the bubble wand on it down into the bubbles. It's gonna wait 2 seconds, and then it's gonna raise it up. And right here, 16. What happens when we set 16 to 1?
It turns on the relay.
It turns on the relay.
Which then turns on that
Right.
random motor we had in a drawer in our
Right.
office.
And so, yeah, it basically, and Josh, the same way you would turn on an LED is we're just turning on this pin, and that pin happens to be connected to a relay, which is allowing our external circuit to fire up, do its thing.
I really like a good relay because I know as a former teacher, I always had all these random parts we had around.
Yeah.
Like mechanical electric buzzers, random like other light bulbs, like using like an incandescent bulb. There's a bunch of like old school incandescent bulbs in my classroom. Things like random motors, and being able to bring those into like a digital environment. We're like, hey, we're gonna turn on an incandescent bulb. How cool is that?
Yeah,
this
right.
LED crud, incandescent all the way, baby. The kids are gonna totally break them. I have to somehow
Yeah.
get them. Good
We
times.
use LED bulbs nowadays, but yeah, incandescent in the old days, right?
Oh yeah. Well,
Although,
most schools
Josh,
still use them.
so you may remember, you probably don't because you seem to forget, but on some of my different sculptures involving relays and light bulbs, and some of them I did use incandescent bulbs because they have that sort of fade down time,
Yep.
versus like an LED bulb, which is like an instant thing. So
Oh, LEDs.
I'm sort of an artist in that regard.
He does have a lot of artistic integrity.
It's just, thank you. So anyway, after our relay turns on, it waits 1 second. And then it's gonna go like, what's it gonna do next? Well, if it's done with all this, it's probably gonna go back to showing our little LED thing here, which you see here, and then it's gonna move the servo again, and it's gonna turn off that fan. So the fan only runs for, well, Josh, let me test you here, 1,000 milliseconds, which is 1 second.
1 second.
And you can change that. And you know what? You're not stuck with just those. You can type in any number you want here.
MS Make Code is pretty slick
Yeah.
as a visual programming interface. I know a lot of
bad.
people use Scratch for with Arduino.
Yeah.
But this is for microbit. You can't go wrong with this, even
Right.
for most projects doing with microbit. You might as well.
Yeah.
You might as well go the route of MS Make Code.
On these servo things, so you could type in the number, but they kind of know that a servo goes between, like
0 and
0 and
270
180,
speed.
whatever. I think you can type in higher numbers as well, but
You can sometimes 270 servos. every now
yeah.
and
So
then.
it assumes your servo might be a 0 to 180, but you can type in something else. So yeah, that's how that works. Is there important information I should know about, Josh?
My force of habit to always look at my email when it comes through.
We're waiting for an email from a foreign dignitary, aren't we?
It's true. A prince has offered to buy a lot of our kits from us if we first help him work out some wire transfer.
Canadian prince. Yeah.
The Prince of Canada.
Yeah.
The Prince of
exactly.
Quebec.
Right. All right. So any questions on this code, Josh? It seemed pretty easy. Didn't it?
Yeah, this is one of those projects where the hardest part about it is just getting your Legos in place.
Yeah.
And really finding a good motor. Actually, I found the hardest thing was we tested a lot of different motors we had out to find one that, one, we had a fan that worked with, and 2, had enough oomph behind it to actually blow the bubbles.
Right.
I also did a lot of testing to see like how close should that little wand be to the fan
Yeah.
to get optimal bubblage, and it did take some testing. Like, how was work today?
Optimal
We
bubblage.
made a machine that blew bubbles, and we spent all day getting what's the best way to blow bubbles with this machine.
Optimal bubblage.
Oh yeah. And I was like, how deep should the bubble material be in there? Which
And-
was something we had to work on. I had to get
Yeah.
like above the little things. Like, it was an interesting day.
Yeah, and Josh, just for a software developer, when they're debugging, or like, I got to fix this problem in my code, it's all digital, but like, ours enters the real world, because we got to figure out like, okay, how long does that wand need to stay in the bubble solution? Is the angle correct?
You got to fill it up enough so it goes over like the end of the circle. 'Cause
Yeah,
you fill it up
yeah,
enough
yeah.
at first, like, why isn't it working? Okay, fill it up a certain amount.
Right.
Good
Try
times.
not to spill bubbles everywhere.
By the way, if you have comments or questions, please throw them into your various viewing area of choice, and we will look at them.
Oh, really? He's asking
Larry.
for the There's a blog
like
post,
that.
Larry. We'll get that to you later, okay?
World's largest cube.
LED cube.
Oh, wait, Pete, should we talk about the world's largest square?
Ah, that's you.
Oh, I'm too hip to be square.
Oh boy. Now, Josh, this code here, you might think to yourself, I want to build this, but hey, whoa, I can't write all this. That's okay, right? Because we have a guide on how to build
We do.
this.
All the things
And
we're going to show off today, we have
we
guides
share our
on.
code.
Now, Pete, we've actually spent a half an hour now on things. We should move on to other projects. I'm sure you've got a few more. to
See
do.
other ones too?
Usually I'm the chatty
Okay,
one.
all right. What,
You got a couple in front of me, too, we can show off.
what would you like to
I don't know.
show or see?
What's next on your tabs?
I mean, we've got, let me read some. We've got distance display, simple level,
Do
the
the-
surprise ghost, tilting. What do you want to
Do
see?
just keep going down the line. Go to the distance display, man. Let's show the
Distance display. All right, let's see
This
here.
is a simple one. This is a really good one. So we're using our bitboard because we can plug in other random things into it, like sensors and servos. But using a really, went this way, using a very inexpensive 7-segment display and little distance sensor. And that's an ultrasonic distance sensor. So we brought that that extension into the microbit code. It's really, really, really easy to output data to a little 7-segment display, and those things are so cheap to purchase.
Yeah.
You can find them, each of those, for like under $5 from a wide variety of vendors on Amazon.
Right.
And you can output all sorts of like nice number and simple letters onto a 7-segment display. Like certain
Right.
letters work better than others. I'll say that.
Yeah.
Z's not so much, but like an H, great. An
Yeah.
O, perfect.
Yes. Josh, let me point out. So we looked at our first code here, and over on the left side, you see there's like a little servo connected. So make code will try to figure out, what you're connecting and give you a little display, maybe an animation if it makes sense. Now this one we are using that sonar for our distance sensor. It doesn't quite know what that is, so it doesn't display that over
Yeah,
there. But
it's
that's
not like
okay.
an
And
officially
you know what?
made
Boop, you
part.
can also just hide that too if you need more room.
away.
But
Gotta
So yeah, this is our code for this one. So again, what we're doing this one thing, we're turning off the built-in LED display because that also uses some of the pins that we're using for other things. So occasionally we want to turn that off if there's a conflict of pins or if we just don't need it. From there, we're setting up our 7-segment display, and again, super simple. One little block here, and we just set our different pins that we've wired it up to. And then our forever, what does it do? It sets the distance, so it's got a variable called distance, and it's reading this piece here, reads the sensor data and sets it to distance, which you can see here.
Now, Pete.
Yeah.
Now, this is something I learned using microbit, where
Yeah.
once you have the display set up in your settings, you can swap out show number as to, like, say, temperature. So display show number temperature, or show number, like, there's a bunch of built-in things, accelerometer data.
Oh, yeah.
So you can actually, like, once you kind of do a couple projects, like, oh, that's how I make the display show things. What other things can I show very easily? It's just like drag and drop like this other variable in there.
Yeah.
Like, okay, sure. That's super easy.
It is super easy, right? Yeah. So again, they give you a lot in here.
Oh yeah, it's got a magnometer on there, so it'll show
does.
like I think compass value
Yeah.
on it. So you can like, which way is north? Make your own digital compass.
Yeah. And Josh, I got to tell you, I mean, I've been writing code for over 40 years. About 40 years.
Pete, you're only 25. How is that possible?
Time travel. But even sometimes, like if I switch languages, I have to look. Okay, well, how does a for loop again? You got to do for, and there's a semicolon. But like for this, it's like, boop, you just drag that in. Like, oh, I don't need to type that, and there it is. Now,
I'm not a great coder. I am a bare minimum.
You
to
are bare
understand
minimum,
stuff,
yeah.
'cause I don't usually do the coding around here. I'm the idea guy. I come up with the ideas. Pete's
That's
the guy
true.
who like makes it happen.
Yeah.
He's the engineer. But even me playing with a microbit, like, oh, this is surprisingly easy. Thank you, microbit, for being decent.
yeah. Now, Josh, if you're like, I don't know, man, these blocks, I like to see my code.
Some
Well, you
people
got
are very codal.
you got two options here.
I will say, because I do a lot of customer-facing stuff and talking
Yeah.
to people and teachers at workshops, the number of adults who are very much anti-block code is interesting.
Yeah.
That the very negative things, oh, kids have to do real-world things. They have to do this. They have to, like, okay, well, you can do microbit or Arduino this way as well.
Yeah.
But or go back and forth, which is really handy, so you can appease both camps.
Yeah.
When it comes down to it, because there have been some very heated discussions on trade room floors about that.
Well, Josh,
not real enough.
as I said, I'm an old-timey, type it all in. And I've used block coding environments before, but a lot of them didn't have this, where you could switch back and forth and
Which is
edit.
important.
Yeah, which is great. And also, if you're like, JavaScript, you can go over to Python. Because, I've written a bunch of Python, so this kind of sometimes makes more sense to me, Now, you can also write Python that does stuff your block view can't really do. And if you do that, I could try something. I don't want to do anything here, but basically it'll show a little block that just says Python code.
Yeah.
Because it can't quite interpret it. It'll run fine. It'll work.
The funny thing about microbit is it actually has far more capabilities than the vast majority of people ever realize, because
Yeah.
you have to actually get into the Python or the JavaScript code to actually do that. And
Yeah.
so it's just kind of funny, like, you can actually do a ton of stuff.
Yeah.
You just have to know what you're doing, which is fine, because I always like to say, like, in a classroom setting, you might have like the 3 or 4 kids in a classroom of 30 that are interested in that.
Right.
And those are your go-getters, your super inquisitive kids. Let them go for that. But for the middle third of your class or whatnot, who just want to do the project in a decent way, get a good understanding, great. That's perfect. And that lower third of kids who are having tons of problems, it's very easy for me as a teacher to be like, hey, Randy.
Right.
Randy. Great kid in
Oh,
my class.
Randy.
Randy, I see you've not implemented several blocks that you're supposed to implement.
Right? Like, it's not.
Oh no, you have no forever.
You
Or
can do
Randy,
this,
your
you can
microbit's
drive
not plugged into the
parts out.
computer.
Like, that needs to go over here. It's got to go there.
Randy.
There it
Randy's
goes.
like 20 now,
So,
probably.
so Josh, indeed. So I think too, we've been using this system for over 6 months, I think.
Yeah, at least.
And I haven't hit anything where it's like, all right, we've done everything, or we can't go any further. It's pretty robust. And again, if I got sick of this and be like, or a student did, you'd be like, all right, hey, tell you what, try to write it in Python instead.
Even some of our bigger projects, which we did a big Lego Ferris wheel, like the big 3-foot tall Lego Ferris wheel.
Yeah.
We modified a Lego motor that is meant to stick into it from the official Lego motor, and hooked up to our relay. And we did a bunch of NeoPixels, big strips of NeoPixels, do like big lights on it.
Yeah.
And the NeoPixel code is in there for doing strips of NeoPixels. That
It
was
is.
easy. The hard
Yeah.
part was building the darn Lego thing. The
Let's see.
code as a whole was just NeoPixels relay.
So is it
How do you want it to work?
NeoPixel. Boom. Look at that.
There you go. And so you can do some
there.
impressive, like I say, the projects that the average person, average kind of,
Look at that.
getting into coding kind of person wants to do. Microbit makes it easy. Not to
It
poo-poo
does.
on
It does.
on Arduino, because we do have a lot of Arduino projects we do as well. But Microbit just kind of makes it a little easier, especially for troubleshooting, because there
Yeah.
you go. Now we've got NeoPixels, which aren't hooked up to the project.
Yeah.
Oh, look,
Nice.
they're showing up in there too.
Right. There you go.
But no, NeoPixels are fun. And they're, again, things that showy projects that people want to do when they're looking at stuff. When you go to a maker fair, like, wow, that looks really cool, I want to do that.
Yeah.
Most of the time, it's lights that blink, sounds that go off, one sensor kind of thing. And the hard part is making it all look nice, like making your
Yeah.
bike light up. It's not tough to do. You just got to attach those lights to your bike somehow. That's the hard part, is attaching the lights to your bike or to your person, to yourself,
Yeah.
your costume. The code is just NeoPixel, and then even then with the NeoPixel, like getting them to do like very specific designs might be the hard part about it. But yeah. Anywho, Pete, what else do you have on your many tabs of Pete projects?
Well, we've got Wally, xylophone, the avoidance robot.
Let's show off the xylophone.
You want to see the xylophone?
Let's hear those sweet, sweet xylophone melodies.
Beautiful.
Pete, that's a melody to Funky Town.
It is indeed.
So this is another one where servo, we can either control it manually with all those push buttons.
Now this one's got a lot of code.
This is more complicated because I think, so Pete, when he was explaining to me, the hard part with setting up the xylophone, which by the way, we're setting up a 3 mallet larger version of this to go with a nice glockenspiel, which is what you call a nice xylophone.
Right.
Not a cheap $6 one you got off Amazon like in that video, which sounds horrible. The hard part is doing the work and figuring out what angles each of the notes are at, and then having like basically a handwritten chart to the side that says, okay, I want to do letter A. A is 37 degrees. I want to do letter B. Well, that's 45 degrees, and so on and so forth. So we have a list of notes equal degree for the servo to go, and then that was like the big thing for this, because once that's in place, it's just a lot of, honestly, it's a lot of just throwing in all the notes.
Yeah.
So Pete, you set up a if statement for like each note, right?
I did. So yeah. So let's
you want big on this one, Pete.
So yeah, in our start, what we're doing first, we turn off that screen, and then we set our mallet up and down angles, because that's going to be the same pretty much for any of them. And then there's a little bit of pause, so when it like strikes, it waits before it goes back up, just so it can travel the full distance. And yeah, so there's a lot of variables in this, and then these are all the angles that the arm has to go to hit the different notes. So I named them, note 1, note 2, etc. And then we set up all our pins, and that's so we can press the buttons to play it.
Mm-hmm. Or if you were being a very musical person on an actual glockenspiel, you might set it to like A, B,
Yeah.
B flat.
That
C.
toy doesn't have those.
No, those just have colors, which
Right.
aren't actually.
And you can't even see them, so.
It is very harsh on the ears, but you know what it is? $6, and our
Yeah.
servo does reach all of them, I think, right, Pete?
Yeah, I
Almost
believe
all.
so.
Yeah, which is why Pete's building
Yeah.
a 6-servo version of that.
Yeah. So Josh, here in our loop, what we're doing, we're just checking each pin. So if it's pin 1, so button 1 is pressed, we're gonna call note number 1. Button 2, we do note 2. So then we've got this thing called call strike note. So strike note is a function, and it's over here. Function is strike note, and what it does is says, okay, we're gonna move the arm to the arm angle, and then we're gonna wait as long as our arm pauses, and then we're gonna put the mallet down, and then we're gonna wait, and we're gonna move. So that's basically a function is a way to have reusable code. So for each of these, when I call strike note 1 or strike note 2, it runs all this bits of code. So instead of having all these commands right here, we can break it out into a function that just gets something called arm angle, and it knows where to go and what to do.
Perfect.
And then we also have a function called Funky Town.
Mm-hmm.
So,
Funky Town.
so right, and here's our thing. We have an extra button over on pin 15, and if you press that, it'll just play Funky Town for you.
Which it's kind of like my go-to like weird song when we do like something weird like with sound effects or
Yeah.
piano, because it's a nice little chunk of notes.
It
that
is.
It sounds different. It's not your twinkle twinkle or whatnot, but it's Funky Town.
Yeah.
And it's just weird enough to get people's attention. But we're hoping with the big glockenspiel that we can do some bigger things.
Yeah.
I mean, I don't think we can go the route of the guy who does all the. Oh, somebody bought something. Okay, go the route of the guy who on YouTube who does all the floppy disk drives to play music.
Oh, yeah.
But once we have the stuff to set up there, you could program it to do any number of
Right.
songs. Once this hard work was there, it's just
Yeah.
basically having the melody in front of you, Imperial March. Okay, here's all the notes are in there for the different, all the glockenspiel things, and you can just do that. And it becomes, the setup is the hard part. After that, doing music is just knowing what notes to play.
Yeah, and we had some other songs as well, so I can, do this, and I can change these. I change all this internal stuff in this function and add another song, so you can move things around and whatever.
Oh no,
delete
Funky Town
things.
is so unfunky now. Lips
But
ink,
yeah,
we
I mean
call
that's the nice part about a function is boop, and do all that, and this is going to be the worst song ever because it's just going to play one note and then it's going to do nothing. So
Oh, it's
Funky
one
Town,
note
that's
song.
Funky Town 2. We'll rename that one too.
You made a one-note song.
Terrible.
That's the thing.
Song terrible.
You could probably patent that.
There you go.
Copyright that.
And you know what? We go over here, and instead of call song Funky Town, we just add in a where's our thing? Our advanced functions. Call song terrible instead. Just put that there and delete that one. Boop.
Call song
Now you
terrible
get-
sounds
you
to
get-
me like, wow.
Call song
Give
terrible.
the programs calling your song terrible.
Solid.
The code knows.
That's all that is. And look at this. Whoop. You can close that up if you want to make a little more room in your editor. Save a little space.
And that's MakeCode. Thanks, Microsoft, for having this free, hopefully forever free thing. By the way, this also works with a few other platforms as well. The Adafruit Circuit Playground. It's on the other big maker board, the popular maker board that's out there for this. Talking with someone today about that here in our shop. Yeah, also with another kind of board that has a wide variety of built-in sensors and functions. I think they're what, $20 from Adafruit.
Yeah.
They're nice.
They have one too that's like for making arcade games. They're all digital. There's no controller, but it looks like a fun thing for kids, students looking to learn some code.
By the way, if you love the microbit and want to go even further, Adafruit did recently come out with their Adafruit Clue, or
the Clue, yeah.
if you want to get
Clue.
no Clue, which is just basically the microbit's older, more successful sibling. It's the same form factor, so it actually works with all the microbit accessories that are out there, but it has a built-in color screen, far more sensors on there, more power behind it, and I think it's like 30 or.
Yeah, and we did a version that worked with the bubble blower.
Yeah, I mean, if you're somebody who already knows all the programming, and want to, like, say, use all the microbit accessories and whatnot that are out there in the ecosystem, so to speak, the Clue is pretty nice for the price point. They're nice enough to send us one, and it's a nice little board. It looks like a microbit, just with way more oomph behind it, and that color screen is really nice too.
Yeah. Let's see this. So we have some. Do we have?
Oh yeah, Pete has the code for the Clue version.
I feel like we had it in here somewhere. That's the. Yeah, we had a Clue version, so I'm not sure where we put it, but it's around somewhere.
It's pretty. Yeah.
Machine.
Good times.
Oh, this one. Oh yeah, it's a Circuit
Python. That's why.
Yeah.
Here it is.
So yeah, I think we added a little bit more code so it had some stuff on the display screen, but yeah, this is it. I mean, that's the amount of code for our bubble machine, really. So
when you have a very pretty color display on your board, you might as well show things off on it.
Yeah.
Just saying.
Yeah, totally.
So what's next on our wonderful tabs of code, Pete?
Well, what else do we got here?
You're a Chrome guy.
I'm using Firefox. I don't use Chrome.
What year is this?
It's the Freedom
open
browser.
Opera and Netscape Navigator, Pete. Come on.
I tell you what, Josh. Let's look at Wally here, because there's some fun code in that one too.
Wally is a kit you can purchase off of eBay because Lego no longer makes it. Because we're a few years late to the Wally craze. We're using 2 Lego-based servos, which they're actually from KittenBot. We sell them. They're just servos with built-in Lego connectors on them. And we have 2 continuous rotation ones on the bottom, a battery pack inside of Wally, because why not? And all we're doing is having Wally just do some different movement. Just go forward, stop, turn.
Right there.
There's nothing, because we don't really we wanted to make it as a fun demo, so throwing a bunch of other random sensors onto Wally would make him not look cool, which is half the point of doing a Wally kit off of eBay. I think they run like $80. It's last I checked.
It's not cheap.
But
Josh, the fun thing is any two continuous servo robot could use this code.
And that's the fun thing, because Pete, we should show off our continuous rotation servo robot we built.
We have one. We have this. Oh, hold on. Oh, that video file is gone. All right. Well.
How? It's on the file server.
No, I know. Ecamm's not finding it.
Pete, we could just show the actual one because it's sitting here on the table.
We could do that.
So we have.
Let me see.
Want to go to the overhead camera? Well, now it's a little overhead. Big Josh. There we go, little robot. Go. Don't go there.
Oh, there's our robot too. We got 2 of them.
It's the same robot.
Yeah, it's the same robot. This one does have the distance sensor on it, I think.
I think the other one did too.
Wally doesn't, though.
Oh no, the Wally doesn't. Right. So this guy he's got a little power bank or a battery pack on the inside. This is our Arduino Nano based robotics board. It's got a bunch of pin headers on there, the Lego compatible components on there. Got a little distance sensor, and we have these 2 orange continuous rotation Lego based servos with just a little. I think these are pulleys with a rubber wheel, a rubber grip on them, which is like the easiest Lego way of making a wheel in Lego Technics. I mean, it's pretty simple. And we also have the really fun ball bearing on here, which we actually, I think, got a pack of generic ones off of eBay ages ago because it makes for a nice third point. Although the version we first did this, we just had just random Legos off the end, just some smooth Legos. Against the floor is a third point of contact, so it just dragged, which actually worked just fine, but the ball bearing does look cooler, so we went with the cool. But this is a fun one because it's so simple to make. The hard part is just making a little chassis for it, but it's just plug in 2 servos, plug in a distance sensor, plug in power, and it's a wall avoiding robot, which is, again, one of those projects that people love to make as their my first robot project. because it's easy to understand, it's easy to make, it's easy to show off, and there's a number of versions of this. And a lot of people take that basic idea and then expand it quite heavily by adding in other sensors, other functions as well. I mean, essentially, add a vacuum on this, Pete, it's a Roomba.
There you go.
No,
for Roomba.
Sorry. It's a Roomba.
Roomba.
Which,
There you go. I don't have a sound. There you go.
the sound of our, wait. It's a paper craft. Found at browndoggadgets.com with its directions and more. It's our robot vacuum. Robot vacuum.
So Josh, just real quick, the code for Wally, and very similar for that little robot. So what we did here is, again, that figuring out I'll say the angles, as it were, is the hard part. So continuous rotation servos are a little weird. You don't tell them an angle like a normal servo, like 0 or 90, but you give them a number, and what happens is they'll either turn clockwise or counterclockwise. So you can see here our stop value is 1600. So if we tell it 1600 for that servo, it won't move. It'll move to like the center, sort of. But if you give it either a 2200 or 1000, it'll turn either clockwise or counterclockwise.
And we should tell people something I always I like to use continuous rotation servos because we have to put them in our kits, and they're a very easy and common thing to find these days.
Yeah.
And they're really easy to power because you can typically power them, a couple of them, especially for small projects, off of your board, or very easily from like a USB power source.
Right.
Whereas if you want to actually get really precise, like nice movement, you want to use two motors and a motor control driver, which actually does control that motor forward and backwards.
Yeah.
Which is the really, really nice way to do robotics, either using a stepper motor, same kind of
Steppers,
idea, or a motor controller driver for a little bit more simple version, cheaper version. But that's why our project, whenever we make one of these guys, it never can go straight because one continuous rotation servo is moving a little faster than the other. Just a couple 2 to 3% more, it just starts going to the side a bit. Again, you wouldn't get that issue with like a motor controller driver or stepper motor to be very precise. But it's a really easy way of making a project like this, or a very small project. So every time somebody makes a really, really tiny little tiny robot or something, probably continuous rotation servos. Be like these little blue 9G sized ones.
Yeah.
We used to use those for some things, but the Lego ones are literally the same thing, just in a Lego-y format.
Josh, I've been building these kind of servo robots for 8 or 9 years, and they're still fun. Again, it's that quickly getting something up and running and moving versus I need to figure out stepper motors and stepper motor drivers and then external voltage supply for it's again, if you want to get there you can, but for quick and easy, get something done, get something working, get something fun, this is the way.
That's the difference between doing a fun project and doing a NASA project, or like a very critical
a deep
project.
investment. You're investing time figuring out, which is valuable.
It's the
definitely,
fun
but
versus the obsessive fun, and we all
Sure.
have our own. We all have our obsessive fun things we like to do, where we put way too much time into a project that nobody else would conceivably put into something.
Right.
Those are called hobbies. Way too much time, effort, and money.
Right.
But for fun projects like this, especially classroom projects, this is something that kids can wire up and have working code-wise in 3 to 5 minutes. Plug, copy the code, or modify the code then from there. Building the body around this, the little bit of the chassis for it, super easy. Again, 5-10 minutes of plugging Legos together. And they can be then having a robot in that 20-minute range of time versus, say, building something larger from the ground up. Although you can take these mechanics and, again, do bigger, better things, not a big deal. But for my first robot, this is surprisingly cool, and the way a lot of people do it. Yeah, motor controller drivers are nice, but you have to have a nice geared motor for it. By the time you had a nice geared motor, actually 2 nice geared motors and a motor controller driver, it's there's $20, $25.
Yeah.
It's versus 2 continuous rotation servos that can be had for $4 each.
Yeah, if you've never built a robot before, getting this code working and moving a physical thing and then being able to mess with this code and change it, it's pretty magical.
Hey, Pete, let's show the Autobot next.
The
Not the Autobots.
What's
we
the
know are
auto?
from Cybertron.
What's the Autobot?
The Auto.
Auto DIY. Oh, yeah.
Auto. So ages ago, some people came up with a really fun little walking robot setup. You'll find this usually out of laser cut wood or acrylic, sometimes molded plastic. Oh, yeah, 3D printed as well. So it really it's 4 servos, typically 4 servos, sometimes 5. They have like a head movement in there as well. Yeah. But you got 2 servos here and 2 servos here to do very simple walking movements. Usually I like to throw googly eyes, or the 3D printed ones always have a little face on them to give a little bit of personality. But it's really just a little cube head with 2 legs. It walks very awkwardly like a toddler that's ready to go down for a nap. But a while ago, we saw somebody randomly had posted like the most basic bare bones outline of doing this setup out of Lego using these Lego servos, which we carry. And we liked the idea, but they didn't have much of a write-up on it. Oh, here's like one. Oh.
Yeah, this is like the official, like, hey, here it is.
Yeah, they've got a distance sensor on this one.
Yeah, there's a lot of variations going from simple to more complex.
Yeah, they've got a bunch of sensors on theirs. Are they using looks like they're using Arduino for this one.
Yeah, I think there's
Arduino
there usually.
But I mean, great. You can do it with microbit as well. We did a version of this with microbit. Just microbit has an issue with more than 3 servos sometimes. We'll have to see if the version 2 can handle it or not. But anyway, very easy to do. The hard part was just figuring it for us, like backwards figuring out all the Lego parts involved, because there's a picture like, you can make this. Here's a picture. We're like, how do you make this? That seems cool. How? And we have enough Legos. We have so many Legos in our shop, all organized. We're like, well, we have most of these parts. Let's see what we can do and figure out the balance of it, because balance is big. And Pete, why don't you roll the video? Enough of me chatting about this guy. Let's show what it looks like in action. What? Did you give it to me? Yeah, we showed it yesterday.
Okay.
Or it's on the shared drive.
Oh, that's right. Yeah, go ahead. Keep talking.
Anyway.
It's because it's not in eCam. Let me grab it.
Oh, so anyway, so we did lots of variations of this, adding little parts and components to kind of balance it out. Balance was the big issue. It kept falling one way or the other, but it does a little fun little acrobatics routine, which is just code we grabbed from somewhere else.
There we go. That's this guy. All right.
So this is no googly eye version. There's a USB cable attached to it off to the side.
Yeah. And this is just the stock code that we loaded. There's a demo code and like does a little dance. Yeah, it's pretty impressive.
And for a My First Robot kind of thing, they're pretty kind of cool because they're fun to show off. Like, I made this, and you can modify it to do different things. Like, here's how it walks left to right and forward. So you can make a fun robot. And the bigger ones have, like that one we showed you from the official one there, has built-in sensors, so you can have it do things and have really make it seem like it has a little personality, which is why I threw googly eyes on ours.
Right.
Because googly eyes equal personality.
Yeah.
But, I mean, it just looks fun.
Yeah, and the fun part for this one was we already had the code loaded, so we had to build. Well, from a photo we saw, we tried to build and then guess and then kind of modify a few things just to get the balance and the weight all right. So
we should,
kind of a good challenge in that way.
We should actually do a full write-up on this, Pete.
Yeah, we can do that.
Because it really hard for the big thing for us is finding out the official name of all the Lego parts. And the official, like, every Lego part has a number, like an official Lego number.
It does.
So finding out the official part number, say, hey, you need 5 a part number 3647.
Yeah.
Okay, great. And then this and this and this. That typically takes a lot of time when
It
you're looking
does.
up like a lot of these components. Yeah, well, there's a few that we typically use a lot of, and I mean, this works pretty decently. I mean, you could probably get all these Lego parts together for like $20 if you went to like Bricklink or Brickowl, brickowl.com, your source of random Legos from people all over the world, bulk Legos. But if you have like a robotics class after school, and you want to have them build a couple of Lego-based robots, because that's a really simple way. If they screw up so badly, they're Lego. You're not out laser cut material. You're not trying to design stuff from scratch. You're not 3D printing pieces. This is a great way to do some projects. And when they're done, they can take it apart and the next group of kids can use it again, or they can build something different with it, which is a nice part about modular systems. They should be able to easy together, easy apart. That's why like both of these guys are really simple, fun little projects to do. These are both using our robotics board from Brown Dog Gadgets. We come some different kits that come with servos and whatnot. Yes, you too can buy wonderful kits at browndoggadgets.com or your favorite educational catalog, or even Amazon.
True.
The store, not the rainforest.
No, don't buy from them.
Don't buy from them. They'll just send you an iguana.
So Josh, the other fun thing, we talked about maybe trying to fit a small LiPo battery and a power booster in it. but I don't know. That's a stretch.
The problem is, like, we don't have that much space inside the head here.
Right.
There really isn't that much room, especially we have a couple pieces like cross bracing some axles to the middle here to hold it all together. So that's one of the biggest issues. By the way, the biggest issue facing technology these days, where do you stick the battery? Because phones are awesome and parts are thin, but you know what are big? Batteries. Batteries are big and heavy and take up room because you have a big screen. Yeah. And for our other guy here, we actually... We bought a couple like random power banks off of Amazon, just little phone charging power banks, and found one that fit in here, and then we plug it in. You could probably use a couple of like AA battery packs in there.
AAA maybe.
Oh yeah, I could get 3 AAA batteries. Yeah. So 3 regular alkaline AAA batteries gives you 4.5 volts, which is just what an Arduino needs to get going. Yeah. So you could somehow configure 3 of them like in. Again, that's not that much. Wire it in, life is good, and
the Lego one, the avoidance robot, like that you could build taller pretty easily for fit.
Oh.
But the Otto, he's kind of the size, you can't really build a lot taller because he'll be too heavy.
Yeah, and this thing it's pretty stable. It's got enough, I mean, it's got enough a low enough center of gravity, or a high enough center of gravity. There we go.
That's a low end.
It's a low rider. do. Well, Pete, I can see by the time it's 3:55. We should show one more project. What other project do you have queued up, Pete?
All right, we have Surprise Ghost, Tilting Maze. We have the simple level.
Let's go with the Tilting Maze. That's my favorite one.
Here we go. Tilting Maze.
Tilt that maze.
Funky soundtrack.
Oh yeah. This is one of my projects I've had on the shelf for years.
Yeah.
I bought that Lego maze. Again, it was a short run from Lego. They made this great project, which is a real tilting maze. You manually turn left and right.
Yeah.
They actually have it's a Lego soccer ball is the part that they use as the ball that's in there.
Yeah.
We just got a ball bearing because it looks better on film. A little heavier too, a little more mass, so it keeps rolling, so you have to have a little more control. But we used a cheap thumbstick, which I don't have any of those parts in front of me.
We also used a ball bearing so we could
at the
trigger
end.
that circuit at the end.
Yeah,
a little light up
because ball bearings are conductive. But we just hooked up 2 of our Lego servos and a cheap little thumbstick because those are so inexpensive. We include those in some of our kits. And so, I mean, it's just...
Those are, for if you want to control 2 servos, that's perfect.
Or even 1 servo, by the way. You want to control one servo left and right or something like that?
Yeah.
It's perfect. It also has a built-in switch as well, which we don't tend to use because it's awkward to press.
Yeah, I mean, look at this. You got servo, move.
I did, Pete, at one point, I made, somewhere on our Instagram feed, I made a little rocket launcher using... that thumbstick where it did X and Y, so you can actually get like a full range of motion, and the click actually activated a 3rd servo, which not a little Lego rocket launcher type thing. We press the back of the rocket, the thing, and it shoots. Where it would actually hit it with the 3rd servo, so it would launch it. And it was it worked, but it was just. The hard part was figuring out how to get the Legos to work together.
Yep.
I figured out the code, not too tough, but it was making mechanically sound was the hard one.
Yeah.
But somewhere on Instagram is that thing. I never wrote it up because it was too weird.
Yeah.
It's some very, very, very specific parts, but maybe one day we can return to that. I always want to do 2, Pete. Was doing it again. I'm way late to the game here, about 10 years too late. But doing like a time lapse rig for say a GoPro.
Yeah.
GoPro cameras are great for doing simple time lapse, and it's small enough. We could hook it up to a Lego setup and just do a very slow pan and tilt. So if you had a maker fair or an event, or you're in a workshop, just plug it into both things into a big power bank or a wall power supply with USB, and then just slowly pan and tilt. So you do that nice time lapse, which looks great. Or you're out somewhere very, very beautiful, set that up and walk away, and it'll just do all the work for you. And take
come back and your camera's gone.
Well, hopefully, unless you're in Japan, because when I was there, people were so nice.
That's good.
They cameras were always left in place.
Well, Josh, like here's all our code for that tilting maze here. That's it. You know, we've
Tilting Maze is, by the way, a great project, and the nice thing about the Lego was the mechanics were already done up in a really great way. You can find that Tilting Maze on eBay for like the $80 to $100. But if you're a classroom who wants to do bigger projects like that, buy the official kit, or you can get all the parts, say from, again, brickowl.com, just buying random Lego parts. You can actually buy all the parts to that kit, say from like a website like Brickowl, and just make it yourself. You just, here's the parts list for all the kits, for all the Lego different kits. You just buy the parts individually, build it with online directions, and it works really, really, really well. And it's one of those projects too that kids really get into. Oh, and the fun thing about that Lego tilt maze is you could pop the maze off. It was designed so the maze section pops off, so you could then redesign the maze and then pop it back on again. So that entire like middle section pops up. Without destroying the project. And it was well designed from a gentleman who does tons of Lego stuff, and Lego they made an official kit of that project of his. But I think this is actually, I think one of the mazes might be the... No, it's not. I did a couple different versions of mazes, some that were very difficult.
I think we asked you to make it easier so we could do it for the video.
So all the parts, all like the random spots of color were actually dead zones, so that your ball would fall into like pits and get stuck. So you had to navigate around them, and it got increasingly more difficult. Problem was very few of us could do it, especially on camera, so we filled it in with all like the blues, the reds, and the yellows. But I made that puppy hard, made it challenging.
Movie magic. Yeah, totally.
Because hey, you gotta make Pete work for the joy. But it's really easy, and I was surprised how well those Lego servos handled that back and forth. The one issue was we're using very thin little green Lego 8x16 plates that we're sitting onto. They flexed a little bit, but in general, like,
I solved that later, but we already shut the video.
Oh yeah, you just put a piece of like a tape loop underneath them to stick them on the table.
Well, and I just built a few Legos up around it too. So
it's again, structural integrity of Legos is sometimes not the best, but they're a great building tool, and mechanics were done. The hard part were the mechanics, which somebody already did for us. Legos, somebody can figure out the mechanics, the gears and whatnot. Electronics is not horrible for the stuff we're trying to do. And that thumbstick is fun because it's the same kind of thumbstick feel you'll find on any modern game controller. I have an Xbox controller, Pete, that I bought years ago, which I broke out to play a certain Star Wars game recently on my computer. And I'm like, this is just like this thumbstick we have at the office on there, even with the click in the middle. So it's a nice, like, you can make a game controller on your own, that real-world connection, which I love doing with kids. Like, look, you can make the thing you already use. You made that. It's like that eureka moment, like, oh man, I can make brownies for myself. I can have all the brownies I ever want.
Not a good idea.
Power of brownies.
Correct.
They just eat a lot of brownies. But this is like, I can make stuff. But it's not a tough set of codes. By the way, these codes can all be found on our website. In case you're wondering. Still watching. If you're one of those fun people still watching. Pete, how many people actually watching?
Says there's 5 still.
5 people after an hour? Wow. Or just people who walk away from their
people.
Computer and forget.
So Josh, again, code here, pretty easy. We had to figure out some of the values, so we're looking for a X and Y value. That's when you move your little joystick. And if it's between, 2 numbers, then we tell the servo to move. Otherwise, we tell the servo to go back to center. Like, it's pretty darn simple, I mean, that's the amount of code for that maze project. So
perfect.
Not bad at all. So Josh, I don't know what else. Is that it today?
You want to show the accelerometer project, which...
Oh, the level?
We made a digital level.
Sure.
Which is one of those things that is very silly. Just show the digital level.
There we go. Let's do that.
I have actually the parts for all this in front of me, but we're not going to make it. Very simple using the built-in accelerometer on the microbit. And you can do an X and Y for this if you really wanted to. Way more work. But it's very, very simple and very easy with a very good cause and effect for kids with a very like, oh, look, we made a digital level. And it's just 5 LEDs.
Yeah.
And it's
And it's a classic. We're reading the accelerometer. It's between it's between a different value. We turn on a different LED, and that's it. So it's a bunch of if-else statements. So
it's
all there is to it.
And something kids could easily modify as well. Same thing. It's one of those things like with the distance sensor. Another good one. If the distance sensor says it's this far away, do this thing. I call the parking helper. The garage parking helper, where you have like
the parking helper.
Yeah, you have like LEDs that the closer you get to when you're driving into your garage, you want to make sure when do I stop. You have a distance sensor on the wall with LEDs, hook up to your microbit and LED, 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 stop.
Yeah.
And super weird little simple project. I've seen people do that with NeoPixels. Fun one with a NeoPixel ring, where it filled in the ring, and then the ring got to the stop point where it needed to stop, and it started flashing to stop. And it's way cooler than the tennis ball on a string in your garage, as long as it's working. But it's one of those things that is kind of it's funky. It's not that tough to do, and there's very real world applications for that. And I always like to say, if kids can show them, if you do an if-then statement with a sensor, if this happens, do this thing, sound, light, motion, they're going to have way too much fun designing really stupid things, which is great. If they're amused and designing their own stupid things, that is awesome.
Right.
Actually, Pete, last stupid thing to show. Let's show the little ghost guy. Speaking of that exact same thing, distance sensor equals stupid thing. Distance sensor equals ghost popping out and scaring people.
And it features our amazing acting. So.
I mean, watch Pete. Watch. Pete.
Oh, it's a prop comedy right there.
Oh yeah, Pete was like, "Oh no, I'm afraid of this thing I've done several times in a row." But distance sensor equals like a servo pops out this ghost. And we had LEDs blinking on it, because why not? And this is like our stupid Halloween prop. But if you're seriously wanting with your kids, or as an adult design like a stupid Halloween prop, drop a spider down, drop a ghost out, servo and distance sensor, so easy to do. And it's just you made your own Halloween decoration. This is the kind of project I always see a lot of adults do. It is pointless. It is fun. It's a cupcake. It's a cupcake project. Cupcakes are pointless. They're just there to give you joy. They have no real-world applications. These are fun.
Pointless.
They're kind of pointless.
Yeah.
But
and again, this is all the code we got for that surprise ghost. Pretty simple.
Yeah, it's when distance was a certain.
If it's more than 1 and less than 75, do this stuff.
Yeah. And pops up, LEDs blink, pop down.
Yeah. Josh, fun fact here. So we're checking if distance is greater than 1 because we found that every now and then that sensor would kick out a 0. Or it would, I think it would kick out like a 0 or a negative number. So we didn't want to check if it was just lower. So I don't know. So
it could be because the older version of microbit, or just in general microbit, tends to put out 3 volts of power as an output. Problem is, most sensors kind of really want to have 5 volts, so a lower voltage might throw out some weirdness every now and then. The distance sensor isn't as accurate on a just plugged directly into a microbit without its own
it's not a laser.
Power. Oh no, it's not. It's a little bit less accurate. Oh no, what would the kids do? But some weird random things do kind of weirdly happen. So having above a 1 and above. I know most of our sensors have no issue. I think the one we were worried about was the distance sensor, but even then, we've had no issues. And even just doing the 7-segment display with the distance sensor tends to still give a pretty darn accurate reading. We had a ruler out and just that's pretty close to where we're at, plus or minus 2% kind of thing. So
but Josh, honestly, this is again one of those things that when you're dealing with anything, you may run into things you don't expect. So originally I had it saying, if the distance is less than 75, but you have to account for things like, what if the sensor shows -4 or 0, because that's not 4. For whatever weird reason. So you have to deal with that. So you add in a little extra in your code to deal with that.
You know what that is? That's a Civilization Gandhi
is that
error. In the game Civilization, Gandhi had a hostile rating of 1. He was super passive.
Okay.
And one of the things you could do in Civilization was to do things to make other people around you like you more, like you less.
Oh.
Well, I think he was 10. He was at a favorable rating of 10, a friendly rating of 10. Well, when he got bumped above 10, he went to -1.
Ooh.
And became the most hostile person in the world. Just nuke everybody.
Right.
Whatever
That's
it was, just a weird error. So you have to take account weird things happening. Which apparently was quite fun. Gandhi would just nuke everybody. Thanks, Gandhi.
No, that's
in
not
the game.
good.
But anyway, that's us today. We are definitely over an hour of code today.
That's why I'm doing the DJ air horn. It means time is up.
I can't hear your sound effects. I refuse to wear
I know you
headphones
can't.
when I don't need them. Look at my beautiful hair. Just got to keep it looking good for
All right. Well, hey, thanks for joining us today. I hope you learned a little about the code behind our projects, and keep coding, kids. Keep coding.
We took the other camera. We had 4 cameras. One of them used to be on Pete, but we rarely used it. And
I took it home.
Yeah, he took it home. So now we just got cameras on me, so we can't do hour of Pete. Yeah, Pete, you should be sitting over here doing the hour of Pete code.
I could do that. We'll do that next year. All
On
right.
that fun note, myself and my small robot friend, little robot friend, are going to go do paperwork. So thanks,
right.
everybody. Find all of our
All
stuff
right.
at browndoggadgets.com. Follow us at one of these many social media links that Pete's going to throw up there. Please,
right.
we post cool projects for free, whether or not you actually like us. So use our projects. Adios.
Okay.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.